Welcome to 10 minutes CS. 1813 Sentence Similarity 3. We are given two strings, sentence 1 and sentence 2, each representing a sentence composed of words. A sentence is a list of words that are separated by single space character and no leading or trailing spaces. And it only consists of uppercase and lowercase English letters. Such as we are given S1 as Hello Jane and S2 as Hello, my name is Jane. We need to find whether these two strings are similar, and they are defined similar if it is possible to insert an arbitrary sentence, that could be any possible sentence, maybe an empty one also, to these sentences such that the two sentence becomes equal. So a note is there that the inserted sentence must be separated from existing sentence by spaces. That means, let's say in Hello Jane, we are adding my name is Jane. So we see that it is separated from the actual sentence by Hello Jane. So let's say we have one sentence as Hello and Jane, and other sentence as Hello with a W and Jane. We cannot insert W here because this is not separated by our actual sentence by a space character. So this will be a false case. Now, what are the possible cases when we can insert a sentence to it? Let's say we have first sentence as my Haley. So in this case, we have it as S1 and we have our S2 as my Haley. So as these two sentences are equal, so we will return true. Now we have another sentence, let's say instead of S2 we have now S3, which is my name is Haley. Here we can see that we can insert name is, which is separated by our actual sentence by space character. So this will also be a true case. And now we have another S4, which is my Haley is happy. So in this case we see that we can insert is happy, which is separated by the actual sentence, which is S1, by a space character. So this will also be a true. And now let's say we have another one, which is S5, and this is she is my Haley. So we can insert she is, which is separated by the actual sentence by a space character. So this will also be true. So what is the inference from these examples? First one is, if S1 is equal to S2, then it's true. If S1 and in S3, we can insert a maybe a sentence, then it's a true case. And with S4, if S1 is a prefix of S4, then it's true. If S1 is suffix of S5, then it's true. So the cases are, if it's a prefix, that is the smaller sentence, let's say S2 is smaller than S1. So if it's a prefix or a suffix, or if it's equal, and the final case will be when the start of the sentence is equal to the start of the other sentence, and the end of the sentence is also part of the end of the sentence. So that means a part of our string is prefix and a part of it is suffix, and by adding both of them it makes the whole sentence S1. So let's try to write all of this in our code. We have length of sentence 1 as L1, length of sentence 2 as L2. Now the case when S1 is equal to S2, it's true. So if the length is equal, that means if the sentences are equal, then it's a true case. Now if the lengths are equal, so it can't be just the prefix or suffix. The only case left when it can be a true is when the sentences are equal. And here we are trying to compute, like just for the ease of use, we are always considering as our sentence 2 as something smaller with respect to our S1, so that we can compare it as our prefix or suffix of the S1. So our sentence 1 will be smaller than our sentence 2. Now we start with our the start of the string, and we keep on checking the characters unless they are equal. So this will compute our prefix for it, and we keep on iterating over it by increasing our start variable. After this, our start will be pointing to the character which is not matching or either the end of our string with respect to S2. Similarly, for suffix, we will check with our N1 and N2. By our N1 is the last character of our S1 and N2 is last character of our S2, and we will check unless it's equal to greater than or equal to 0, and we keep on decrementing it until they are equal. So at the last of this loop, our N1 and N2 will be pointing to those characters which are not matching. So now we will check for the case when it is a prefix, like our S1 is a perfect prefix for our S2. So that will be when our S1 is completely exhausted and we have reached to the last of S1 string. So that is what we are checking here, if the start is equal to our S1's length, and as it should be separated by a space character that we are checking in our sentence 2. So let's say here we had my Haley and we had my Haley is. So in these, after the traversal, our start will be pointing to here, and we check if our start character is equal to an empty character and our start is the last character of L1. Similarly, for the case of suffix, we will check if our N1 is equal to -1, that is, it has exhausted our S1 string and it has bypassed the 0th character, so it will be pointing to -1, and our N2 for our sentence 2 is a space. Now this is the case when we had my Haley and my name is Haley, example. So in this we are checking. Now our start will be pointing to this and our end one will be pointing to this one, and our end one will be pointing, end2 will be pointing to this one. So in this case it's checking if our start is greater than n1, that means that we have an overlap here, and we are checking if our sentence 2 start -1 is a space and our end 2 plus 1 is a space. That is, the arbitrary sentence that we are adding in here is actually equal, has spaces in front and the last of the sentence. If this condition is met, we return true. Else, if we are not able to find it as a prefix, suffix, or an insertion sentence, we return false for this case. The time and space complexity for this, as we haven't used any extra space, we are just using few variables, so our space complexity will be constant. But for time complexity, we are traversing over the string here, 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 but we are just traversing it once in each of these cases, so it will be big O of n. Let's try to submit it. It is the exact same code that we had there. Let's submit this. It's indeed passing all the test cases. Thank you for watching.